on how to manually construct a normal probability plot. I had a few questions about it. So this is coming from chapter 6.5 part 2, and it does give you these exact same detailed instructions, but typically we would not generate a QQ plot by hand. We're going to use some sort of technology to do it, but it's helpful to understand what the technology is doing and what a QQ plot or normal quantile plot is showing. And so we're comparing each X value or the individual sample data to a corresponding z-score that we would expect to see if this was a normally distributed set of data. So we first need to sort the data from least to greatest, and then we're going to give each data value its own corresponding proportion. So if there are a sample size of n, each value has 1/n of the sample. When we have a sample size 5, each value is 1/5 of that sample. So proportionally, we're going to use that to find the corresponding left area for the normal distribution. We find that using these fractions, 1/2n, 3/2n, 5/2n. You keep going until you have n values. And then we use the standard normal curve to find that corresponding z-score. You'll use technology to do that. Match up these corresponding z-scores to the sorted data values and then plot them. So the example in the textbook is from a Dallas commute times data set. It's pulling 5 of the commute times. So we're looking at the times 20, 16, 25, 10, and 30 minutes. So we only have a sample size of 5, and we're going to take that sample and sort it. So we've got 10, 16, 20, 25, 30. Then we want to find the cumulative left area proportion for that sample value. We have a sample size 5. When I plug that in, we should get 1/2 times n. So 1/2 times 5 is 1/10, 3/10, 5/10, 7/10, and 9/10. This gives us the decimals that we see here, 0.10, 0.30, 0.50, and so on. Each value would have a corresponding z-score. So if I'm finding the z-score for an area to the left of 10%, it would have a z-score of -1.28. I can use Excel or other technology to do that. In Math 152, we used Excel and we used the command of norm.inverse. Norm.inverse with an area to the left of 10%. You'll change that out for 30%, 50%, 70%, and 90%. Its mean is 0 because this is a standard normal curve with a standard deviation of 1. That's how this is calculating the z-score of -1.28. When you continue to do that for each value of the area to the left, you would get the following z-scores. There are 5 of those, so that should match up with each sample data value that we had. So the lowest one was 10. That should have a z-score of -1.28. Then we had 16 minutes. Its corresponding z-score is going to be -0.52. We keep doing that for each one and then create a plot of this. Now I'm going to do one of these on Excel to show what's going on. I've got the commute times here already sorted. And to do norm.inverse, this one had an area to the left of 10%. Its mean is 0, standard deviation is 1. That's how we got that -1.28. I can do this for a probability area to the left of 30. And then that would be 0 and 1. So -0.52. And you do that for each one. All right, so we've got all of these z-scores, and if I wanted to create this QQ plot by hand, we can just insert a scatter plot where the x values are those individual sample data values and y is the corresponding z-score. This is showing me a QQ plot. I can name this or rename this a normal quantile plot. And when we're analyzing the QQ plot, we're looking to see, does it form a somewhat straight line? A drastic deviation from a straight line might indicate this is not a normal distribution because it's not following what we would expect out of a normal distribution based on the z-scores. Hopefully that helps answer some of those questions that some students had. If not, send me an email and we can work back through some of these.